Think about how you find a book in a library. You walk in with something you want, a question sitting in your head. The books on the shelves each advertise what they contain through their titles and index terms. You match your question against those labels, find the closest ones, and walk away with their actual contents. Believe it or not, that is almost exactly how attention works, and its three ingredients even have names: query, key, and value. Understand these three, and the entire attention formula stops being mysterious. Let's dig in. First, let's contrast this with the kind of lookup you already know cold. A hard dictionary lookup is all or nothing. You hand it an exact key, and either it matches perfectly and hands you that one value back, or it fails outright. There's no notion of similarity, no blending, no sense of a book that is almost what you asked for. It is a rigid, exact match and nothing else. Attention is a soft, fuzzy version of that same lookup. Your query is compared against every key by degree, not by an exact match. And instead of grabbing one value, you take a weighted blend of all of them. Close matches contribute more, distant ones contribute less, and the whole thing is smooth and differentiable, so it can actually be learned. Look, mechanically it comes down to 4 roles, and once you see how they connect, the formula practically writes itself. Follow them one at a time. Start with the query. Each token is projected by a learned weight matrix into a query vector, and that vector encodes what this particular token is looking for elsewhere in the sequence. Think of it as the specific question this token is quietly asking the rest of the sentence, its own little search request. Next come the keys. Every token also produces a key vector through its own separate learned matrix, and the key advertises what that token has to offer. The label other tokens will match against when they come searching for relevant information. Now match them up. A token's query is compared against every key with a dot product to measure relevance. And those raw relevances are then scaled and pushed through a softmax, so they turn into weights that all sum to 1. Finally, the values. Every token also carries a value vector, its actual content, and the output is the weighted sum of all those values, using the weights we just computed. Keys decide how much attention flows. Values decide what actually gets carried. Strip it down, and 3 ideas capture query, key, and value. Every token gets 3 learned projections. From each token, 3 separate weight matrices produce a query, a key, and a value. And those matrices are among the main learned parameters of every single attention layer. Query and key together decide the weights. Matching a token's query against all the keys, then applying softmax, sets how much attention flows to each position. This is the addressing half, the part that chooses where to look. Values are the content that gets blended. Once the weights are set, the output is just the values combined in those proportions. Keys decide how much, values decide what, and cleanly separating those 2 roles is the whole trick. All right, let's lock in the essentials. Query, key, and value are 3 vectors, produced from each token by 3 separate learned weight matrices, sitting at the heart of every attention operation. Think of it as a soft search. The query is what you want, the keys are what each token offers, and the values are the content you retrieve. The query matches against every key to set the weights, and the output is those weights applied to the values, so addressing and content stay cleanly separate. When a token attends inside its own sequence, all 3 come from that same sequence. In cross-attention, the queries come from one, and the keys and values from another. If unpacking attention this way finally makes it click, there's plenty more waiting